Okay, so this is the first problem on the practiced second midterm. The problem is asking to find the intervals of increase and decrease for the function f of x equals 2x cubed plus 3x squared minus 36x plus 17. The key principle that we use for problems like this is that if the derivative of the function is positive, the function is increasing. If the derivative is negative, the function is decreasing. So therefore, to find intervals of increase or decrease of a function, we need to calculate the derivative and then determine where that derivative takes positive values and where it takes negative values. Let's begin by calculating the derivative. In this case, it is fairly easy to calculate the derivative. We differentiate term by term, and for each term we use the constant rule and the power rule. And so f prime of x, the derivative of f, will be 2 times 3x squared plus 3 times 2x minus 36, and then the derivative of the last term in our function, 17, is 0, because 17 is a constant, it does not change, and therefore the derivative of that term is 0. So this is our derivative. Let's simplify it. 6x squared plus 6x minus 36. Now, what we need to do next is determine for what values of x this derivative is positive and for what values of x this derivative is negative. And it is convenient to accomplish this by first calculating the points or the values of x for which the derivative is 0. These are called critical points. So I'm going to set this derivative equal to 0. And we will solve for x. This is a quadratic equation. We can solve this in different ways. We can solve it by factoring. We can solve this by completing the square. We can solve this by using the quadratic formula. In this case, it's fairly easy to factor the derivative, this quadratic polynomial. So first I'm going to factor out 6 to get 6 times x squared plus x minus 6. And then we can factor it further to 6 times x plus 3 times x minus 2. And so now we see that this function has 2 critical points, which are the points where the derivative takes value 0. And these critical points are negative 3 and positive 2. Okay. So these are the values of x for which the derivative is 0. What we need to do next is determine where the derivative is positive and where it's negative. In order to accomplish this, I'm going to draw the number line. This is the x-axis. On this number line, I will mark the critical points, negative 3 and positive 2. And you will see now that these 2 critical points divide the number line into 3 segments. From negative infinity to negative 3, that's our first segment. Then from negative 3 to positive 2, that's our second segment. And then from 2 to positive infinity for the third segment. The derivative is equal to 0 at negative 3 and 2. Everywhere else it is not equal to 0. And so everywhere else it's either positive or negative. Additionally, in order for the derivative to change sign, in order for it to go from positive to negative values, or the other way around, the derivative values have to go through 0. They can't jump from positive values to negative values without going through 0. And so for this reason, the sign of the derivative stays the same on each of these 3 segments. And therefore we can determine those signs by simply testing the derivative, values of the derivative at some test points. It doesn't really matter which test points you take. So for example, I can take -5 or any other in the first segment as my test point from the first segment. I'm going to select 0 as a test point on the second integral, and I'm going to select 3 as my test point from the third segment. Now, what we do next is we look at the value of the derivative at these test points. Now, we don't really need to know what the value of the derivative is at these points. We just need to know if the value is positive or negative. In order to determine whether the value of the derivative is positive or negative, it's best to use the factored out form of the derivative. So I'm going to use this form right here. Plugging in x equals to -5 gives us 6 times -5 plus 3 times -5 minus 2. And now you see that this value is a product of 3 numbers, where the first one is positive and the other 2 are negative. And so the result is going to be a positive number. And the conclusion that we make from this is that the value of our derivative is going to be positive anywhere on the first segment, not only at -5, but also at -6, or -4, or any other point on that first segment. So I will make a note of that, and I will put a plus sign above that first segment. Now we determine the signs of our derivative at all remaining test points. For example, if we use 0 for x, we're going to get 6 times 0 plus 3 times 0 minus 2. Now you see that the first factor in this product is positive, second is positive as well, but the third one is negative, and so the result is negative, and we have negative values for our derivative on the second segment. Finally, the value of the derivative at the third test point 3 is 6 times 3 plus 3 times 3 minus 2. Again, I do not really need to calculate what this is equal to exactly. I just need to know whether the result is positive or negative. And since all 3 factors here are positive, the result is going to be positive. So greater than 0, and we have positive values on the third segment. And now we can tell that on the first segment, the function is increasing. On the second segment from -3 to 2, it's decreasing, and then it's going to be increasing again on the interval from 2 to 3. From 2 to positive infinity, sorry. And so the problem was asking, let's look at the question again. It was asking about the interval on which the function is decreasing. Well, looking at our results, we see that the function is decreasing on the interval from -3 to +2, and that is our answer.